here we have our next topic, which is angle of depression. So when looking down to an object, the angle of depression is formed by an observer's line of sight and a horizontal line. The angle of depression is congruent to the angle of elevation because they are alternate interior angles. So let me try and draw another diagram for you all. Okay, so this time, imagine that this is you again as the observer. So this is you. And the angle of depression is the angle between the horizontal line from the observer and the line of sight to an object that is below the horizontal line. So this is depression, angle of depression. So you can think down. So this time you are looking down. So you're looking down to some object. Let's just call this the object right here. And this time the horizontal is here. And this would be the angle of depression. So this is the angle of depression. You're going to have your line coming down here. This would be a right angle. And as said before, there are alternate interior angles. And the alternate interior angle is actually, the other angle is right here. So these two angles are congruent. So if I say that this is 5 degrees, then this one would also be 5 degrees. So whatever your angle of depression is, this angle here would be the same amount. But to make it general, we're just going to call this X. So we're just going to call this angle X, which means this is also X. So that is angle of depression. Going back to the problem, it says a lifeguard is sitting on a platform looking down at a swimmer in the water. If the lifeguard's line of sight is 8 feet above the ground and the angle of depression to the swimmer is 18 degrees, how far away is the swimmer from the lifeguard? So there's already an image drawn here, but I'm going to do my own. So this is my lifeguard. My lifeguard is sitting on some platform and he's looking down. That's not really straight, but the lifeguard is looking down at a swimmer. We'll just call this the swimmer. In the water. If the lifeguard's line of sight is 8 feet above the ground, so this would be the 8 feet above the ground. Right here. The lifeguard's line of sight is 8 feet above the ground. Be careful that you don't mistake this for the line of sight being 8 feet. It says the line of sight is 8 feet above the ground. So it wouldn't be here. It would be here. So that's where 8 feet goes. And it says the angle of depression to the swimmer is 18 degrees. So this is the angle of depression because this is our horizontal line. But remember, we have alternate interior angles. So we also have 18 degrees right here. Now what the question is actually asking us is how far away is the swimmer from the lifeguard? Again, don't mistake this for the line of sight because they aren't asking us for this. They are actually asking us for X over here. So how far is the swimmer from the lifeguard? So this is X. Let me erase this here. So now we have our image. Of course, this is a right angle. And again, we're going to try to figure out which trig function we need to use. So we're going to look at our reference angle. And our reference angle is 18 degrees. in relation to that 18 degrees, we know that 8 is our opposite and x is our adjacent side. So we're going to have, you guessed it, tangent. So we say the tangent of 18 degrees is equal to opposite, which is 8, over the adjacent side, which is x. Multiply x on both sides to get it out of the denominator. And we have 8 is equal to x times the tangent of 18 degrees. Divide by the tangent of 18 degrees, and you will have x is 8 divided by the tan of 18 degrees. Put that in a calculator, and you will get 24.6 feet. Let's go ahead and try another example. So here we have another example. It says, a pilot in a helicopter spots a landing pad below. If the angle of elevation is 73 degrees and the horizontal distance to the pad is 1,200 feet, what is the altitude of the helicopter? So let me go ahead and start drawing. So we have a pilot in a helicopter. Let's just say this is my helicopter. Here's the pilot. He's in a helicopter and he's spotting a landing pad below. That's the landing pad. Let me just go ahead and draw a line right there. Erase. So he's spotting a landing pad below. If the angle of elevation is 73 degrees and the horizontal distance to the pad is 1,200 feet, what is the altitude of the helicopter? So the angle of elevation is 73 degrees. I'm going to draw my horizontal right here. We have a 73-degree angle here, but we also have one right here. Because alternate interior angles are congruent. It says the horizontal, remember horizontal is left to right. So this is left to right. The horizontal distance to the pad is 1,200 feet. So this is the horizontal distance. You know that this is 1,200 feet. Here's my right angle. Now they want to know what is the altitude of the helicopter. Remember, altitude means height. So this would be my x. This is 73 degrees. And that's my x. So what is the altitude of the helicopter? My reference angle is 73 degrees. And in relation to my 73 degrees, we know that this x is opposite and the 1,200 is adjacent. Here we go, tangent again. So I'm just going to write SOHCAHTOA here anyways, even though I know it's tangent. So we're going to say the tangent of 73 degrees is equal to our opposite x over the adjacent, which is 1,200. Multiply 1,200 on both sides. These cancel, and you're left with x is 1,200 times the tangent of 73 degrees. X is already by itself, so you can go ahead and put that in the calculator. Get a decimal approximation of 3,925 feet. One last example. Number 7 says, building A is 480 feet tall and building B is 654 feet tall. If the angle of depression from building B to building A is 42 degrees, how far apart are the buildings? So this one can be a little tricky, but we're going to try to draw this as best as we can. So here is, I'm just going to draw a line to represent building A. This is building A. Or just say this line, that's building A. And building A is so this line is building A. Building A is 480 feet tall. And building B is 654 feet tall. So I'm going to draw building B slightly higher than building A. So that's building B. And building B is 654 feet tall. If the angle of depression from the top of building B to the top of building A, so the top of building B is right here to the top of building A, which is right here. I'm going to connect these dots. Here we go. The angle of depression, here's my horizontal. That's 42 degrees. Remember, we have alternate interior angles. So that would make this angle over here also 42 degrees. How far apart are the buildings? That's the actual question. So how far apart are the buildings? That's going to be X. So here we have our X. Now you might be wondering, this is the triangle right here. I'm going to highlight the triangle. This right here is our triangle. And you might be wondering, where's the other side that we can use for our trig ratio? Well, this is how you get it. So you know that this entire building of building B, this entire side, let me use a better color. We know that this entire side right here is 654 feet. And this building is 480 feet. So if you subtract those two, you'll find the difference in height to be, so if you subtract, you do 654 minus 480, you'll see that that is 174. So we know that this right here is 174 feet. And that's how you find the other side. So we're still going to look at our reference angle. Our reference angle is 42 degrees. In relation to our reference angle, we have an opposite and an adjacent side. So tangent again. So we have the tangent of 42 degrees is equal to our opposite, 174, over the adjacent side, x. Multiplying x on both sides, these cancel. Now you have x times the tangent of 42 degrees is equal to 174. Let's get rid of this right here. So now we have to divide both sides by the tangent of 42 degrees. And you have x is equal to 174 over the tangent of 42 degrees. Put that in the calculator to get a decimal approximation, and you will get 193.2 feet. Now, you might be asking, is it always going to be tangent? We've been using tangent a lot. No, it's not always going to be tangent. Just make sure to always look at your reference angle and use that reference angle to try and figure out what trig ratio it's going to be. That's all for angle of depression.
D-Rock, 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 D-Rock.